Welcome everyone. So my name is Arkadiusz Giedrojc and I'm representing Arista Networks. I'm responsible for Arista for the Polish market. And I'm running this presentation together with Kulin Shah, who is the system engineer responsible for many large technical customers in the West Coast in the US. And we will be focusing on this presentation on the evolution of the merchant silicon. So, as Arista Networks is a quite new kid on the block on the networking space, I would like to spend a few minutes on introducing Arista, what we do, what we are focusing on, and what are the major strategic decisions we have done and major advantages. And then we will go into the merchant silicon state and how it's developing and why is it important. So Arista Networks was founded in 2004, and the main founder of Arista Networks is Andy Belholmstein. And Andy is a guy who was the first investor in Google. He founded Sun Microsystems, and he created the first Ethernet switch. And then Arista created the first product, was issued 2008, but we've done the IPO on the barrier of $1 billion. So the last 2016 financial results was $1.2 billion, which is quite an achievement from the financial perspective. Since 2015, so for the 15 and 16, we've been recognized by the Gartner as a leader in data center networking switching market. And as you can see from the graphics on your left down, we are constantly growing our market share in the market that we are competing. And from this perspective, I would say that it is quite an achievement. The company is quite successful. And I believe that there are many factors which are contributing to this success. They are not only technical, but there are many others which are more strategic nature. So one of the things that we have really based our future and make a strategic decision is that we are not going to develop our own chips, that our all development is going to be on the merchant silicon. And why we have done it, I mean, the reasons behind it, you will see how the merchant silicon is going to develop. We will see later in the presentation. The second thing is that what we have really focused on is that we have foreseen the development of the cloud computing. And the main advantage Arista had at the beginning was that how to build a new switch with a new operating system, which is designed from bottom up to be for the new data center and for the cloud data center. And one of the building blocks of our differentiation is the unique operating system, which we called EOS, which is really making separation between software and the state of the box. So we are holding the state of the box centrally, and the software is communicating with this database, making the really resilient design and very easy for program and automate. So based on all of those elements, and later on also on focusing on very narrow market, which means data center. So we are going to do only what we do the best. We will not produce our firewalls, WAN routers, access, wireless. We are focusing mainly on our core business. So it allowed us, for example, to have one operating system for all our product line. It's one binary. It gives us also a lot of advantages. But one of the really fundamental the decisions we have done was about the merchant silicon, that we will not really invest in our own. And I would like to right now hand over to Kulin just to go into the details, why we believe so and how this market is changing.
Me? Nope. No. Okay. So first of all, good afternoon. It's a tragedy that we're doing it in English because I learned Polish over the last week just for this presentation. But but we have two people who don't understand Polish. It'll be a 1-hour presentation then. So anyways, I'm here to tell you a little bit about merchant silicon, what we've seen, the decisions we've made, and sort of what we see going forward, and the reasons why we feel merchant silicon is important in the data center, and which is now the proof is in the pudding. You see a lot of other vendors actually now beginning to use merchant silicon, even though they've traditionally prided themselves in building their own ASICs. So first off, just some background. There's obviously different kinds of hardware you can build. There's FPGAs, there's gate arrays. Typically, the decision comes down to between semi-custom and full custom ASICs. And full custom ASICs is what we call merchant silicon in the networking space. And effectively, there is some fundamental differences. With semi-custom ASICs, what you do is you get predefined libraries. There are certain limitations and restrictions as to what you can make the chip do, because it's more of a top-down approach where the application for the chip is already pre-decided, and then you build the design keeping the application in mind. With merchant silicon, it's sort of the opposite. It's a bottom-up approach where it's very low level. You look at the wafer size, you look at the number of transistors you can squeeze in, you look at the trade-offs between buffers, table sizes, memory, right, and the pipeline, the feature flow, and you decide what is it that you want to incorporate in that chip, and then you design it sort of bottom-up, and that's what we call, or the industry in general calls, merchant silicon. The advantage to that is the focus is primarily on speeds and feeds, so you want to get the maximum bang for your buck. That's what gives you sort of high density, 25, 50 gig, 100 gig, obviously. But more importantly, there is APIs that are built by the vendor. What that means, it allows consumers of these merchant silicon, like Arista, to write code to it and to be consistent with that code. So when new chips from the same family come around, we already are used to the APIs. We already know how to interact with the hardware resources underneath, and that allows us to consistently, build stable software and keep writing new features for newer chips with the least amount of development cycles. So you're not sort of restarting every time a new chip comes out within a family. Typically with Broadcom, the two most popular families are Trident and the Petra Dune family products that they acquired. But if you look at the APIs and the shells, they're completely different. So even if a vendor says we actually build chips with Broadcom, that doesn't mean that they're familiar with all the APIs or the shell, because the differences are pretty big. And we'll get into the details of why that's the case. So a little bit of background, apart from these details, is our background. As Arka mentioned, we were actually founded as a software company in 2004. The idea was to build an operating system, a network operating system, but actually not sell switches, not sell hardware switches. Within 4 years, we realized very quickly, with talking to a lot of customers, that that's not what the industry wanted. Customers wanted a operating system that was integrated with the hardware and completely supported, right? This was the number one sort of requirement from the customers we saw earlier on, which led to the point that we actually looked at the state of hardware at that point. And some of our founders have designed the Catalyst 4000, the Catalyst 6000. We're all from ex-Cisco teams. And the conclusion at that point, and two other trends that were happening at that point, everything favored in terms of merchant silicon. And that's why today, EOS is one binary image across all our products, because the very founding principle of our operating system was you can pick any ODM switch and run our software on it. Of course, today, that's not the case. We have our own hardware, but it's still the same binary across our entire product portfolio, whether it's a VM that you can use for testing, you can download for free, or a big chassis that goes in cloud data centers. Exact same binary. Same bugs exist across all the... We don't have any bugs, but just in case there were... No, we do. So what really happened at that point was sort of the uptick in the server speed market. So this is circa 2008, 2007, when the transition from north-south traffic patterns was changing to east-west, which meant there was a lot more traffic and bandwidth needed within the data center, not just leaving in and out of the data center. The second reason primarily for this was sort of the complexity of the application itself. And as more and more layers got added within the applications, again, that drove the bandwidth requirements within the data center. All of this, which is basically Moore's law of the CPUs, increasing, virtualization getting adopted, meant the bandwidth needs were a lot higher, but networking in general wasn't keeping up with Moore's law, right? The amount of cost you needed to upgrade your network within the data center was really high, and that it was typically oversubscribed north-south designs with layers of switching, which meant it was a big inertia for customers to upgrade in a cost-effective manner. All of this sort of coincided during the time when companies like Intel, Marvell, Broadcom were coming out with their latest generations of networking ASICs. And this is what we latched onto. The timing was perfect, and this is what we saw as sort of the future. And we've stuck to that strategy ever since, but now you've seen the industry actually gravitate towards what we've been doing for years. In general, you can see effectively in terms of the attach rates, 2016 was the year when 10 gig sort of was the dominant factor, but now you'll slowly see 25 gig and even 50 gig effectively surpass 10 gig in the next 2 to 3 years. So 2019 is what we predict is sort of the year when 25 gig, 50 gig actually goes past 10 gig. The reason being 40 gig was a very complex technology. The fiber upgrade needed, the rip and replace needed, as well as the cost of the transceivers was a big reason why 40 gig didn't get adopted as quickly or as easily as people thought. And so a lot of the deployments started at 10 gig, but now it's a lot easier to move to 25 gig because it's still, a single lane. It's 25 gig SerDes, it's one lane standard, so all you do is you upgrade your NIC and you can still use the existing fiber. And it's a marginal increase in cost, which is about 1.2 times the cost of 10 gig, and you get a 2.5x bandwidth advantage. So virtualization, application complexity, pushing more bandwidth out the server, and the cost on the network side not being a big deterrent means that you'll slowly start seeing a lot of 25 gig adoption. And to match that with the merchant silicon bit, a lot of the vendors are now focusing on actually building 100 gig, which is effectively 4 by 25 or 2 by 50 on the chips itself. So those trends are, again, lining up really well going forward. And a good example of sort of, keeping up with Moore's law in the data center space or in the networking space is you can take the example of Dune, which is now owned by Broadcom. Is their first generation of chips were the Petra chips. These were 8 by 10 gig chips. There was a 3x increase in speed when they moved to the Arad products, which was 6 by 40. And the current shipping products that Arista has are built on the Jericho chipset, which is the third generation, and that was another 2.4, 2.5x speed increase. And of course, looking forward, Jericho 2 takes it all the way to 18 by 100 gig, that's a lot of density in terms of I/O on a single chip. And if you sort of timestamp, this progression curve of the bandwidths of Moore's law onto a timeline, you can see from sort of the characters might not be visible at the back of the room, but basically the Trident family, if you follow that curve, the Trident Plus, which came out in 2012, was a 64 by 10 gig chip. This was a 2x jump in 2 years to 128 by 10 gig, and then today we have the Tomahawk, which is a 32 by 100 gig chip. Then moving forward, of course, we're looking at Tomahawk 2 and Trident 3, which will be another 2x, 3x rev of the speeds you get today in another 2 years sort of time frame, right? And these sort of benefits we pass on to our customers because at the end of the day, we don't have a large team trying to design ASICs. The cost of taping out an ASIC and the timeline it takes to actually build it out is huge. And that's why we're not sort of, investing on that. We know the best of breed vendors. This is their bread and butter. This is their core business. So what we do is we're best of breed. So it doesn't have to be Broadcom. We've announced chipsets with Cavium. We're looking at Barefoot Networks, which is a startup in Silicon Valley. We have chips, switches built on Intel chips. So it's really whoever's the best in the market and whatever is the best of breed, which has the right combination of table sizes, features, and I/O port density, which our customers need, we're going to build products with those chips. And that keeps it, well balanced, because then we have a multi-vendor strategy too. Another sort of example would be, if you look at merchant silicon, it's very easy to say, well, everybody uses the same chips, so it's the same switch. What's the difference? What's the value add? Which is not really the case, because we've worked with these chips for about 9 to 10 years. We've done things with these chips which are not doable. There are things which are not even defined in the data sheet. So, for example, the Jericho chipset supports 250,000 routes in the hardware. We've taken our switches using the same chip to actually do full route tables. We support 1 million routes. This is all hardware features. So the difference is, if you've used a specific set of APIs in the shell over a period of 10 years, you've obviously learned some tricks as you've gone on. The second advantage is a lot of these APIs and shells, they're easy for another customer to adopt and use, but they're very slow. So when it comes to our largest customers, the clouds, the Web 2.0, the Facebooks of the world, etc., the convergence times is very important. When BGP fails, for example, we've been able to bypass the Broadcom shell completely and program straight into the chip. So that means whenever there is route convergence, this becomes critical as you put our switches on the edge of a data center doing full route tables, right? Or even in a 64-way CMP spine. We've actually had advantages where we've improved conversion times by 10x, by 15x, by actually bypassing the shell and programming straight to the chip. So there are these differences which become important when you deploy a switch in production and when you run a network in production. Of course, on the slides, everybody can say, right, that they all use Trident 2, so it's all level playing field. But that's not the case, right? So our experience and what we've done with these chips over the years goes a long way. Something crashed over here, but all right, we're back. So this brings me to sort of the next point, right? Which is, what are the usual trade-offs when you design a chip using merchant silicon? Like we said, you can think of this as a quadrant, and the 4 quadrants would be your sort of I/O density you get, the table sizes and the buffers that are important, the sort of feature pipeline or the packet flow, whether it's an encapsulation like GRE or VXLAN that you want on the chip, and finally, of course, cost. It's a sliding crossbar, which is, if you want a chip that has more ports, you're going to compromise somewhere on either buffer sizes or tables or some kind of feature functionality. And that's why Broadcom, even though it has the Trident family and the Jericho family, they're actually 2 completely different chips. The Jericho family actually has deeper buffers. It has the ability to do 1 million routes in hardware. But if you look at the chip itself, it's a very low I/O density chip. So the Jericho is a 6 by 100 gig chip, whereas the Trident 2 or the Tomahawk are 32 by 100 gig. But they have shallow buffers. They'll do a lot lesser features when it comes to the pipeline, right? And that's sort of the trade-off that you make. The advantage with Arista, again, is we don't build our own ASICs. What that means is we actually are involved in the initial design process of these vendors, where they come to us looking onward as to what is the next sort of rev of chip that they should build, what is sort of the port density and the features that you think would be important 3 years out, 5 years out. Because we're talking to the customers that are actually using these chips in their hardware, in their network, right? And that helps us sort of give our inputs to Broadcom, but also closely work with them, with other vendors, whether it's Cavium, Broadcom, XP, to build these ASICs out, right? And this is critical. Lastly, in terms of the whole silicon design, of course, these are the trade-offs when you're given a given sort of node width and the wafer size. All the chips you see shipping today are on 28 nanometer silicon. Soon you'll see chips coming out in sort of the 16 nanometer space. And of course, there is a good evolution and a roadmap to just the progress you'll see and keeping Moore's law alive, basically. So note that when you go from 7 to 5 nanometers, that looks like a very small, improvement, but it's actually a square function, right? Because that's the length and the width of the node. So that's actually a 2x improvement, because 7 times 7 squares, 49, 5 squares, 20. So you actually get a 2x improvement, which means that's 2x the I/O ports, that's 2x the ability to add more features or buffers or tables. And with current shipping silicon in sort of the 2016 timeframe, we can already do full route tables. We've already sort of surpassed the term of merchant silicon switching. It's almost doing routing today, right? Given there are certain caveats, but we're replacing a lot of routers in big production networks by just merchant silicon. It's still the same price. It's still the same benefits of, the speed at which these chips are made, but you're now getting the benefits of routing functionality as well. So that line is sort of blurring, which this slide sort of talks to, right? Jericho was the shipping ASIC last year, which now does 1.2 million routes in the hardware and has MPLS EVPN capabilities in the chip itself. And we're writing features now to support that. And this is a big change. This is a big drive. And this is the first time we're seeing Arista move out of the classic leaf spine designs in the data center to sort of the edge of the data center, right? Whether it's a simple enterprise edge or a WAN aggregation design, or even peering. So a lot of the largest content streaming customers are completely based on Arista. That's because the fundamental point that you're a CDN, you have to be present in as many locations as you can, and you can't afford to keep buying expensive routers and keep replicating that footprint. So they want all the price benefits of merchant silicon, but at the same time, they want the data center class, software stability, feature velocity that they're used to with these routers. And that's sort of the perfect combination for them when it comes to Arista, because we are adopting merchant silicon, so we're keeping up with pace, forwarding the price benefits, to them, but also we are very proud of our software, and we're basically a software company. We're 90% software engineers, and that's our absolute number one focus. So this is just an example of what we did, right? In 2014, that was the Gen 2 of the Jericho family. There was no support for sort of full tables. So this was a strictly data center product, right? You couldn't put this at the edge. It cannot even do a one full table, but it's still sort of the main switch that's used in spine designs in some of the largest clouds in the world. Moving out with Jericho, we've announced the next generation of products. Still the same chassis, right? We've always believed in sort of return on investment and protecting that investment of the customer. So our Gen 1 chassis that shipped in 2008, which was called the 7500, can consume Gen 3 line cards that shipped in 2016. It's not a four-click upgrade. You can still use Gen 1 and Gen 2 line cards combined with the same soup, the same fabrics. This is unlike anything that our customers have seen. The last thing they want to do is, keep forklifting their network every 2 to 3 years because our strategy is fragmented, which it's not, right? And we've stuck to that. Of course, we have a newer chassis today because the one limitation we ran into was power footprint. Our backplane still supports all the speeds and feeds with 100 gig, even though the first platform was 10 gig. But it was the power footprint that we ran out. When you put 100 gig optics, there is a big power draw. And that's why we had to basically release a bigger chassis with more power supplies effectively. That was the only difference. And again, this is in line. We can do all this because we've adopted a merchant silicon strategy, because Broadcom, because Intel, they have a strategy of building these chips out, in a strategic manner. And we can consume these chips and roll them into our products. And of course, you get all these benefits today at list price of under $3,000 for a 100 gig port. And that's something phenomenal. That's the price point you're getting for basically a router at 100 gig speeds. This is very important if you're a hosting provider, if you're an IX, if you're a content streaming customer, because your end consumer, your core business is a lot about your infrastructure being built out as quickly as possible, as cost effectively as possible, while charging, not passing over those costs to your customers, because that's the only way to retain them. And this is the benefits that a lot of our customers in the IX space, in the content streaming space, have seen with us, and effectively gone with Arista for all those reasons. So I'll finish with 2 slides about what merchant silicon has changed on the design front. So typically what we saw, the original legacy design was, you have your 3 tiers of switching in your data center, then you've got your additional layer at the edge. We pioneered the whole leaf spine design, which was A switch is just a functional block. It's bandwidth, and you scale out instead of scaling up, which means as you grow your data center, you're not adding tiers of switches on top. You're just adding switches horizontally, and you're scaling that bandwidth. So you're going from 4-way CMP to 64-way CMP, for example. It's effectively a 16x increase in scale, right? Without really adding additional layers of cost and complexity when it comes to cabling, switching, support, etc. But with Jericho, which is where the line between routing and switching sort of blurred, customers are now adopting us with the same principle even on the edge, which is you can scale out your edge now with merchant silicon. And you're deploying the edge switches, which can do full tables. And again, because it's one operating system, you're sort of deploying this across all your switches. It's the exact same binary image that's going literally from the switches connecting to your end host all the way to your IXPs and your IXs and your cloud connections at the edge. And this is a huge operational benefit, right? Software, but at the end of the day, it's merchant silicon that's driving the possibility for these designs to change. And then lastly, like I said, our focus will always be and has been completely data center. These are sort of the fringe benefits we get of customers who love us and adopt us in the data center. They want that same operating system. They want that merchant silicon advantages, the price advantages to their peripheral points in their network. And that's why we've sort of expanded in more in the service provider space when it comes to whether they're building their own clouds or a cloud DVR use case, for example, which is nothing but a content analogy, or the sort of WAN aggregation space, where the fundamentals remain the same and they're very similar to the data center space, right? Which is, I want a lot of bandwidth, I want a stable operating system, and obviously I want a certain set of features that I need, but with absolute state-of-the-art stability and support that goes on all these boxes. And that's what we see in terms of where we've moved, in terms of the kind of customers adopting us and the use cases that we're seeing outside the data center space now. So we have about 4 minutes. That's all I had from the presentation. You guys had any questions? Yeah. If it's pricing related, then it's Arca. It's not.
No, it's not pricing. Now, within a single hardware, let's say a line card or top-of-rack switch, have you ever needed to combine two different silicons from different incumbent vendors? Or is it usually a choice of one within the hardware?
Right. So the technical answer to that, there's a commercial answer to that too, but the technical answer to that is typically you want consistency in terms of table sizes, in terms of buffers across that line card, right? Because the last thing you want to do is tell customer port 1 through 16 can do full tables, but 17 through 32 can't, because it's a different chip. That's how they're connected. But the real reason is typically you get additional benefits, whether it's sending proprietary bandwidth speeds like high gig, if you're aware of high gig with Broadcom, where you can actually send a higher speed rate than the link because it's the same family of chips. You can actually design more effective, better products. We did do one switch at one point, which was kind of creative. It was one ASIC and one FPGA combined, and the ports were split. And that was a product primarily for the high frequency trading customers, because what they wanted to do was be able to switch packets in the ASIC, but also do some application-specific manipulations to the router feeds, the feeds they get from Thomson Reuters or whatever, and then send out the transactions to place the orders from the switch itself. They didn't want the packets to even go all the way to the server. So they wanted to basically write their application in Verilog, put it on the switch itself. And that was the one example where we actually had two different vendors, which was an ASIC and an FPGA, within a switch, but that was an extremely, sort of niche targeted use case. But typically, no, we wouldn't see that, mainly because of the simplicity of, the table sizes. We want to keep it consistent. Flip side is we have 29 shipping products today, so it's really easy for us to replicate the same sort of front panel look, but with different chips inside. And that's why the Jericho has a deep buffer, so that goes in storage, high performance compute applications. But then compute could be tried in two, and that helps with.
Thanks.
Sure.
Thank you.